All right, I'm going to go ahead and work these problems. This is the problems that have the most work to them. So read the instructions, change to radical notation. Radical means this, y'all. Womp, that's that. And then simplify. And then simplify. So we're going to spend some time on these. So let's just start by changing this into radical notation. First thing I'm going to do is I'm going to draw this. I know that the 4 is going to go here. And then it says this entire thing is raised up to the power of 1. So I'm just going to leave it. So I'm just going to write then 64 x to the 5th, and then that's it. Technically, it would look like this, right? But since I know it's raised to the power of 1, I don't have to write that whole thing, so you can see my thought process. I'll just rewrite it. When I raise everything to the power of 1, it just stays the same. So since it stays the same because of that number 1, I can write it like this. Now it wants me to reduce this. Now it's saying simplify. Remember all those rules that y'all have like avoided learning and doing this? Well, guess what? We're back again learning how to do this. I'm going to separate this into the best possible thing that I can. So with that said, let me find my numbers. All right, this is how I'm going to do it. It basically wants me to now simplify this apart. So I'm going to take the 4th root of 16 times the 4th root of 4 times the 4th root of x to the 4th times the 4th root of x to the 1. Now, we've done this many times. Y'all are still struggling on this. I understand. Now's the time to master this. How did I pick these numbers? Well, the first thing I did was I generated my number list. Since I'm dealing with 2 to the 4, what I did is I wrote, or the 4th power, I wrote 2 to the 4th, which is 16. If you write down 3 to the 4th, what is 3 to the 4th? You get 81. So 3 to the 4th is 81. You can see that that's bigger than 64, so we're kind of stuck with either using 16 or nothing at all. 16 does happen to work. The 4th root of 16 is 2. Notice I'm going to replace it there. The 4th root of 4 does not simplify, so it just stays like that. Notice this rule. This number divided by this number is how you figure out how to do this. So I've explained this multiple times. I've split this up. It started as x to the 5th right here, and I split it up based on 4 and 1. Why? Because 4 plus 1 is 5, which is our rules for multiplying together exponents when it's radicals. And then, and then I just went based on the biggest multiple. So inside of 5, I found 1 4, and then the leftover was 1. So 4 divided by 4 is 1. So we're going to end up with x to the 1. You don't have to write that if you don't want to. When this number is smaller than this number, it's stuck. So now you're stuck here. Now you have to recombine this whole thing back together. So what's inside the house? Don't forget your 4. What's inside your house is 4x, and what's outside your house is 2x. So that's how you do that number. I'm going to switch color and do B now. So here we go. Let's go ahead and rewrite this correctly. So we're going to have the cube root of 54 x to the 4th. And now, can you see how I have that? I have that because technically this whole thing gets raised to the 1, like in example A, but I'm not going to do it. So how do I break this apart? Well, you have to basically generate your number list. Here's your 3. So you go over here and you start generating your number list. 2 to the 3 is 8. All right. 3 to the 3 is 27. Now I'm going to go to 4 to the 3, which is, 64? And you can see that 64 is bigger than 54, so we're not there. So it's either 8 or 27 that matters in these examples. And in this case, it's going to be 27. So watch how I break this apart. 3 times 27. There it is. Mutter to myself as I do this. And then check out how I'm breaking apart the letters, the variables. X to the 3rd times. A lot of y'all will watch this example and you'll be like, oh, you always split it over with 1 left over. It is not always split over with 1 left over. It can be more than that. It just happens to work out that way numerically. Why? Check it out. I have x to the 4th here, and I want to break it apart in chunks of 3. There's only 1 3 inside of 4. And so when I break it apart into x third, how many do I have left over? 1. So now let's go evaluate these one at a time. And if you're wondering where 27 times 2 came from, again, I've taught this a lot. If you still don't have this down, you're going to need math time or come to see me, because about half y'all don't have this down fully. You're good at the squares, but not the cubes. With that said, I'm going to go ahead and do this. The cube root of 27 is in fact 3. There is no cube root for 2. Well, there is, but it's decimals. 3 divided by 3 gives me 1, so the house disappears and there's a 1 there. This number 1 is less than 3, So then it's just stuck inside. And now we're going to go ahead and put it all back together. Here's my house. What's inside my house? I have a 2, I have an x. And what's outside my house? I have a 3 and an x. So that's basically my work for how to do example B. Now I'm going to go ahead and switch gears again and solve this relatively quickly. Here I go. This is kind of fun. I'm going to rewrite this there. Notice the 3 halves. So I'm going to draw my house. I have this entire thing, 4x, raised to the power of, I'm having a brain fart, 1 second. Raised to the power of 3, the square root house there. Now, this is one of those things. Notice the instructions say simplify. So it's odd, but you're not quite done with this. So watch what I do. Here's the square root. 4 cubed is 64. And then remember there's a 1 here. 1 times 3 is x cubed. So now this wants me to break this apart. And this is pretty fun. 64 is a perfect square. So I'm going to write the square root of 64 times the square root of x squared, times the square root of x to the 1. Again, these examples are showing all the 1 left over, but it's not like that. You're just looking for the multiples that make the most sense. With that said, the square root of 64 is 8. 2 divided by 2 is 1, so that gives us x to the 1. This number is smaller than this number, so now you're stuck. And you can just leave it like that. And now you got to reconstruct the house all the way together again. And let's see, you have, on the outside we have 8 and x. That's great. And on the inside you have x to the 1. And since this is a 2 here, you don't have to write the 2 here. If you want to, you can, but that's it. That's basically how we do that one. So now I'm going to switch ink one more time, and I'm going to solve this last one. And here we go. So I'm going to start by getting this set up correctly. So it's the cube root of 4x to the 5th, raised, that's terrible 5. I'm trying to get those better. Raised to the 5th, and then raised to the power of 2. So that's how this works. So now I have this cube root, but I have to square everything in here. So here we go. Cube root of 4 squared is 16. X to the 5th raised to the power of 2. That's 5 times 2 gives me x to the 10. This is going to be another example with a 1 left over, but it's not just having a 1 left over. So pay attention to that when you split up your x's. So watch how I split this up. I generate my number list. 2/3 is 8. 3/3 is 27, which is bigger than 16, so that's junk. We want 8. So check it out. Cube root of 8 times cube root of 2. 8 times 2 is 16, times the cube root of x to the 9. Notice I'm looking for the biggest multiple of 3 inside this number, which happens to be 9. And then what's left over when I'm done? There's a 1 left over. So now let's evaluate. Do I have a cube root of 8? I do. The cube root of 2 stays the same. And then 9 divided by 3 is 3. So that comes out as x third. And then this number 1 is smaller than this number. So it's stuck. It just stays stuck in there. So now let's combine our house together. And we end up with what's on the outside. 2 and x is on the outside. X to the 3rd is on the outside. And then on the inside is 2x. And that is our math for the day.